Uncovering Nettie Stevens, the scientist behind the XY sex determination system. Before the early 1900s, scientists were unable to conclude what determined an organism's sex. In 1905, American biologist and geneticist Nettie Stevens discovered and named the X and Y chromosomes and saw their influence on gender based on research she did at the Bryn Mawr College. Stevens bridged many frontiers with her work in cytogenic studies and her groundbreaking role as a scientist. When the discoveries of Stevens were first published, some biologists had their doubts. Yet nowadays, her work has become a fundamental concept for genetics. In the early 20th century, a pioneering scientist by the name of Nettie Stevens made a discovery that would change our understanding of genetics forever. This is the story of Nettie Stevens and her pioneering work on the XY chromosomes. Nettie Stevens was born in 1861 in the small town of Cavendish, Vermont. She was a bright student who excelled in her studies, but she faced many obstacles as a woman in a male-dominated field. Despite this, she was determined to make a name for herself in the field of biology. After finishing her undergraduate studies, Stevens faced difficulties in finding a graduate program that would accept a woman. She took a position as a high school teacher, but didn't give up on her dream of becoming a scientist. Eventually, she was able to earn a master's degree at Stanford University in 1900. At age 39, early in 1901, Stevens moved to Bryn Mawr College, close to the city of Philadelphia in Pennsylvania. This was where she began working for a doctorate in cytology, and where she found a mentor in the renowned geneticist Thomas Hunt Morgan, head of biology at the time. Under Morgan's guidance, Stevens began studying the chromosomes of different species of insects, especially including mealworms and beetles. She noticed that the chromosomes of the females in these species were slightly larger than those of the males. Intrigued by this observation, she decided to investigate further. Through her meticulous research, Stevens discovered that the larger chromosomes in the females were actually a pair of identical chromosomes, which she called X chromosomes. She also found that the smaller chromosomes in the males were a different type of chromosome, which she named Y chromosomes. This significant discovery of the XY sex determination system was a major breakthrough in the field of genetics. It's important to note that at the same time, another scientist named Edmund Beecher Wilson independently discovered the same sex determination system using different methods and published his findings in the same year as Stevens, which led to some confusion in the scientific community. Her discovery was met with skepticism and resistance, particularly from the male-dominated scientific community, many of whom dismissed her work as insignificant. However, Stevens' discovery and research was more extensive and provided more detailed analysis than Wilson's, making her work stand out. It was then eventually acknowledged that both Stevens and Wilson made important contributions to the discovery of the XY sex determination system. Wilson's research was not only limited to the discovery of the XY chromosomes, he also did important work on the cytology of the cell, particularly on the nuclei. He also made a major contribution to the understanding of genetics by describing the linkage between genes and chromosomes. Despite her contributions, Stevens did not receive the same recognition as her male colleagues at the time. Her work not widely recognized nor acknowledged, but her legacy has since been recognized, and her work is now remembered as pioneering and trailblazing. After her discovery, Stevens continued to study chromosomes and genetics, making several more important contributions to the field before her untimely young death of breast cancer in 1912 at the age of 50 in Baltimore, Maryland. Her work laid the foundation for the modern field of genetics and continues to be studied and cited to this day. Stevens' discovery had a significant impact on the field of genetic counseling, allowing for the identification and diagnosis of genetic disorders related to sex chromosomes at an early stage, and allowing for the development of more effective treatment and management plans. It explained why males and females have different physical characteristics and behaviors, laid the foundation for our understanding of genetic disorders that are linked to sex chromosomes, and provided evidence that sex is determined by chromosomes, not by environmental factors as previously believed. Her discovery also sparked further research in the field of genetics and led to the development of new techniques for analyzing chromosomes and genes. This has provided a deeper understanding of the genetic basis of many different diseases and disorders. Her work also opened the door to the discovery of the genetic causes of many inherited diseases, including colorblindness and hemophilia, which were previously thought to be caused by environmental factors. This discovery was not only groundbreaking in terms of science, but also significant in the sense that it was way ahead of its time, as most scientists were not able to come to a similar conclusion for many years. This discovery placed her at the forefront of biology. She stood out among her peers, and her pioneering work was soon recognized by her colleagues. Today, the field of genetics is constantly advancing, and new technologies such as genome editing and gene therapy have the potential to revolutionize the way we treat and cure genetic diseases. Her discovery provided a genetic explanation for the differences between males and females, and the legacy of Nettie Stevens lives on as her pioneering work continues to inspire and inform the research of scientists and medical professionals around the world.